header, capital M, M, LD. And then if we compare it also with some information from the object itself, for example, that we know that the offset of the memory mapped module at the offset 12 is the string which describes the name of the module. So this is also great method to recover, to find information about module entries. And the last thing is detection of the modification of the memory. So as I said, that we perform the offline detection. So the methods are a little bit different. And what we can do is to perform the cross-view verification. So we can take the, for example, the kernel image file from the file system and try to compare the content of the text section with the data which are mapped in memory. And this is an example how can we compare if the system service table was modified in memory or not. So to find out where in memory the system service table is, it's quite easy because if we know at least one process, so this process contains the pointer to the kernel treat, and from the kernel treat we have information about the service table and about the address to the service table. It's a little bit difficult if you want to find the system service table in the NTOS image kernel file. But we know that the debug section, for example, exports some information about some functions, and we have to identify functions which are neighborhood, which are next to each other. For example, NT all locate UITs or NT all locate virtual memory. And we have to find these two strings, which are the addresses of this function. And this way, this is the output from the IDEA Pro, and we will see that this is for sure the system service table. So the next thing is to compare the content of the addresses which points to the functions. As I said at the beginning, that some operating system leave the data even after these data are released. I mean, for example, if we execute some process and this process was terminated, so still is the chance to recover this file. On the Linux operating system, I performed some tests. Even after week or two, I could recover the file, the process which was terminated. And what we have to do? For sure, we have to enumerate all page frames. And we have to take a look at the following information. Address space struct, IMA-E map field is cleared, so it means that it's no longer used. But all page frames are linked, and they point to the rest of the page frames which contain the content of the process which was terminated a long time ago. So this also allows us to recover the whole file. On Windows, it's impossible because it's impossible to do such thing because Windows clear all information about the structures which describe the process which was terminated. So, of course, we could recover some content of the page frames, but it's impossible to correlate them with the other, for example, page frames which were allocated by the same process. And finally, I would like to discuss some tools which can be very useful in performing analysis. At the moment, we have two types of tools. The KNT tools, written by George Garner. These tools allow us to dump the physical memory from the Windows 2003 and even Vista because of the driver about which I mentioned before. And also the KNT list tool, which can be used to analyze, to performing analysis of the dump. And also the tool written by me, Windows Memory Forensic Toolkit, which could also be very useful in performing offline analysis of the physical memory. So just to conclude, I hope that you make sure that memory analysis should be a part of the forensic analysis because of the information which could never be stored on the file system and because of the anti-forensics methods. So I would like to thank you, and now if you have some questions, please ask me. And if you want to see these tools, and if you want to see the demonstration, which was impossible to see here, so please ask me at the break and I will show you. Thank you.